Good morning, and thank you for attending our presentations. This morning, I'm planning on introducing the activities of the machine shop to those who may not be familiar with its existence. And for those that are, but may not appreciate the scope of what can be done in the machine shop, I'll be providing some examples of the type of work that is routinely done. As the slide here indicates, this is a campus-wide resource, and it wasn't always intended to be a campus-wide resource. The machine shop itself was proposed, or at least the shop concept was proposed in 2003 to NIH, and this was part of, it was one of 5 cores that were proposed to come into existence to make neuroscience investigators, to provide core services to neuroscience investigators and the laboratories on campus. Well, the idea was a hit. The machine shop certainly was fully funded in 2004, and we had a 5-year grant, which provided absolutely full support for anyone choosing to use the service. Well, it's not hard to imagine that that pricing structure was a very popular idea, and the shop was inundated with work. It still is very well inundated with work, but then it was particularly busy, and folks from all over campus came to use the service, and no one was turned away. Although we were supposed to be focusing specifically on neuroscience investigators, they were not neglected or diminished in any way. But it was a broad service provided to the campus. Well, we didn't receive subsequent funding because we had strayed too far from the neuroscience mission, and we turned into a fee-for-service operation in 2010 and have been ever since. The shop facility is located in shared space on the ground floor of Building 500 or Fitzsimmons Building, and it has been from the outset. The mission of the shop is completely consistent with that of the one core, as Guidon talked about earlier on. And our goals and the services that are provided are listed for you here. Originally, we were intending to simply offer up customized machining services for any type of part or device that may be needed by investigators on the campus. That could have been a very small part, simply a one-off that no more of them would be made, or it could involve the completion of a large complex project. It quickly became apparent that not all investigators came to the shop knowing fully what they wanted, nor some of the technical issues that may be involved in creating the project that they had in mind. So it was decided that designing and consultation services were necessary in some circumstances. There are folks who come in with very detailed drawings. They know exactly what they want, and those drawings are passed on to me, and I can bring to reality those ideas. But oftentimes the project evolution does involve a series of steps of consultation, design, prototyping, perhaps revamping some aspects of the project until it's completed to the user's satisfaction. And then on occasion, and it usually started with a crisis email in the middle of an experiment when a piece of equipment might break, that the shop could offer up an opportunity for instrumentation to be repaired or brought back to working order. And a number of projects have been undertaken there, and at great cost savings, I might add, in the face of replacing what may be very expensive equipment. Well, like all cores, I like to boast that the machine shop employs state-of-the-art equipment, and a couple of examples of the main pieces of equipment are shown for you here. The absolute workhorse of the shop is a 1989 Bridgeport 3-axis computer numeric controlled milling machine. This is an incredibly versatile machine, and virtually every project has at least some aspect of it involving work on this machine. There are 3 milling machines total in the shop at this time. The other one that sees a lot of use is a 1974 Lagoon milling machine. This is a fully manual machine, as you can probably tell on the right there. It is a very large capacity machine, so it really can step up when larger projects have to be undertaken. The second type of machine that is fundamental to any tool room operation is the lathe. And lathes are unique in the kind of things that they can do. The shop is fortunate to have 3 lathes of slightly different sizes, so the range of work can be accommodated when required. The workhorse lathe happens to be a hardened super precision lathe, which is shown here on the left. This lathe is from the mid-1970s. It's been retrofitted with a servo mechanism to allow for a full spectrum of metric and imperial threading capabilities. And this comes in, well, it's essential for the making of microscope optic adapters, for example, or stage adapters for microscope projects. The pride and joy of the shop, though, is somewhat of an antique, although it's fully functional and in outstanding condition. And this is a 1943 Monarch 10EE tool room lathe. Both of these machines are considered to be the absolute pinnacle of tool room lathing. So it may seem a bit of a stretch to suggest that this is state-of-the-art equipment, when in fact it really isn't. The Monarch, for example, is still in production today, and it's a great cost to purchase a new one. These machines are all in pristine condition. They're very carefully maintained, and they're extremely accurate. These aren't the only pieces of equipment that are required, and a good bit of ancillary tooling is present in the shop as well. I won't dwell on these things except to point out that one of the key issues in precision work involves the use of precision measuring devices. And some of these that are available to the shop are shown in the lower right here. The shop services are very widely used. As I mentioned, it is a campus-wide resource, but as you can see here, universities across the United States and even in foreign countries use shop services. I'll comment a little bit more on that in a minute. Fundamentally, however, investigators within the Neurotechnology Center affiliated departments are the main users of the core of the machine shop. I don't have a percentage for you, but it's probably on the order of about 60% of the jobs that come in are for the NTC departments. And then the core facilities are very big users of the machine shop as well. And these include the advanced light microscopy core, the behavioral core. I'll show you some examples of projects for them in a minute. Ryan Williamson's IDEA core is a big user, and the in vivo neurophysiology core has also been historically a large user. But campus-wide, investigators are more than welcome to utilize shop services, and even the facilities group on campus comes in when they're in a pinch to have some things done. I mentioned universities across the US. Some examples are shown for you here. And it should be said that every one of these folks has had some exposure to the shop prior to coming back to me to have work done. Interestingly, even folks at CU Boulder come down here to have some work done, mostly of a neurophysiologic type. And CU Boulder has a very exquisite shop that they could turn to. So why they're coming to me, I don't know, but I certainly welcome their projects. And then frankly, there have been international folks who have used shop services as well. And there are private research institutes that have come to the shop to have projects done, although that's fairly rare. I mentioned the behavioral core using the shop fairly heavily, and some of the projects, this is only a small handful of the projects they have done, are shown here. But a couple of them are noteworthy because it's oftentimes not possible for a shop or a lab to get a hand on some of the equipment that they may need to carry out the experimentation that they wish to engage in. An example of this would be the chamber here, which utilizes a technology called frustrated internal total reflection. And this was constructed from data that were incorporated into a published paper, and the behavioral core wanted to implement this particular experimental paradigm into their services. So we followed the data that we had from the paper and constructed this device. And it works beautifully. It allows for automated gait analysis of rodents that are moving back and forth within the chamber. And their footprints are very dutifully recorded using a camera that is mounted underneath the floor. The resolution is quite impressive. In the lower right-hand corner, over here, get my mouse to work here, is a novel idea that was the brainchild of Nicholas Biscay. And this is another advantage of the shop, where an investigator can come in with an idea, we can flesh out the details required to make what's needed, and then send this off to the lab for testing. Currently, the hexagonal mazes that you see here are being evaluated and validated as a behavioral paradigm. Another advantage to the shop would be illustrated by these pore salt chambers that are shown right here. And these chambers are used as an evaluation of depression in rodents that are placed in these chambers that are filled with water. Well, we were able to construct what was needed based on Michael Mesch's input regarding the size of these chambers at great cost savings to the behavioral core. And finally, the example of these circular open field mazes here in the upper left shows the mixing of ingredients, or not ingredients, but materials to produce an experimental device. So this is a composite of aluminum along with expanded polyvinyl chloride, which leads me to bring up the idea of the variety of materials that can be used in the shop for manufacturing things. There's a heavy dependence, at least on the behavioral core side and in many other projects, for the use of a variety of different plastics, acrylic and polycarbonate being the most common. But there are many other plastics that can be used. They have different properties that make them well suited for different applications. This slide is intended to give you some idea of the wide variety of projects that come through the shop, from the very small, which I'll get into in just a minute, to some of the larger ones that are shown here. Materials that are shown here are stainless steel in the upper left. This was a project that was undertaken many years ago. It is a chamber that is machined out of solid stainless steel rod, and it is designed to house high-performance liquid chromatography columns that are packed at 3,000 pounds per square inch. So the design of this had to be fairly carefully worked out. It was affectionately referred to as the bomb by the folks that used it. It never did explode, however. Aluminum is a very commonly used project material. Here's an example of a chamber that was milled from a solid aluminum block, which allows for the very rapid freezing of brain specimens prior to their being put on a microtome. Recording chambers of all sorts are manufactured. This one is for hippocampal slice recording work, has an integrated heating element so that the environment within the chamber can be carefully controlled with an exogenous heat controller. Faraday cages, these solid Faraday cages are quite large, and they're made out of sheet aluminum, and they provide outstanding electrical isolation properties. This chamber here was one of the more complex projects that were done. This is a sound isolation chamber that was completed early on when the services of the shop were completely free. It's large enough to actually have two people squeeze inside of this. It's not very comfortable, but it is fairly spacious for a chamber that is intended for housing microscopes and electrical recording apparatus. It's very effective at isolating all extraneous noise. This is an example of a mixed project which involved utilizing nylon, high-density polyethylene, polycarbonate, and the manufacture of virtually every part on this board, with the exception of the electrical components in the shop. And this is an olfactometer. Many of these have been made, and this is an example of one of the projects that was shipped off to Chile. And then up here in the upper right, we have a good example of Ryan Williamson's work. He devised a automatic pellet dispensing device, which offers up a pellet to a mouse reaching for the pellet as it's emerging from this apparatus. And then they record with high-speed cameras the behavior of the mouse in terms of its reaching capabilities. Every component, with the exception of the micro switch, was made according to Ryan's instructions within the shop. And again, we were able to tweak or revamp the initial design to better suit his final needs. And then finally, a wide array of very intricate projects has been made, and there's a couple of examples of these are shown for you here. Oftentimes, people will ask for knockoffs of commercial products to be made, and that's perfectly fine. This is an example of a patch clamping suction electrode that was made. Many of these are made in the shop and are available to users. Here's another recording chamber that allows for perfusion and drainage of the slice chamber. We have a stainless steel ear plug here, which allows for the direct application of sound waves at this tip against the tympanic membrane of the experimental animal, with the simultaneous recording through this channel of the amplitude of that signal. This micro drive unit here is kind of consistent with some of the things you've seen in the previous experiments. This one is intended to allow for octetrode placement and advancement within a mouse or rodent brain. The peak wheel here allows the advancement of the tetrode array on micron scale. The cap screw here is machined out to allow the insertion of a grin lens for visualization of parts of the brain as well. So this is a versatile little device, which quite a few of these have been made. And then there are some oddball projects. This is an example of a nitinol stent that was made for the Department of Pediatrics. This was for evaluation of placement of obviously a stent to maintain patency and vasculature in newborns, although I do not engage in making medical devices, so I'll put that disclaimer out to you right now. And perhaps one of the most fascinating and complex projects that was undertaken, and which utterly required the use of a CNC machine, is this array of zebrafish embryo orienting devices. This is a mold device which is intended to create depressions within an auger gel such that zebrafish can be placed in very particular positions for automated imaging. And you need a dissecting scope to see the detail that exists in each one of these little pieces. I wasn't able to get an adequate photograph, but I think you can see here from the detail diagram that we are working on sub-millimeter scale here. And this is complex in the sense that there's a ramping element to this, and then we're down in the 300 and 400 micron range with very careful angular orientation to some of the components of this piece. A great many of those were made. And then finally, I'll use this as a very good example of a very intricate project that was made for otolaryngology. And this is an adapter that mounts to the base of a microscope. And it's a joystick, a mechanical joystick that actually positions a little mirror assembly that exists down here. You can't see it. And it allows for the positioning of a laser beam directly onto the tympanic membrane of the experimental object down here. This device was made at a tiny fraction of the cost of what the laboratory was quoted as in order for replacement to occur. And the savings to the lab was on the order of several $1,000s. So the machine shop is quite capable, through an example like this, of reverse engineering an existing commercial product and bringing that product into your laboratory. The pricing or the cost of projects is based exclusively on the amount of time it takes to complete the project and the cost of materials. It's a very simple formulation. The initial consultation time for projects is free to the client. And then the shop labor rates are tiered as they are for others, with $68 per hour being the labor rate for NTC affiliated departments and $92 per hour for outside departments. The shop is staffed by myself, and the shop is in operation from Monday through Thursday weekly, and it is located on the ground floor of Fitzsimmons Building, room NG003, and that's in the northwest corridor of the building. I will open up the opportunity for people to come have a look at the facility if they wish. And I will say that if you wish to visit the facility during the times that I'm there, if the green light on the card reader is lit, then the door is unlocked, and feel free to come in and I can show you around. I'd like to provide acknowledgement for the support that is provided to the machine shop. User fees go a long way toward supporting the activities of the shop, but they do not completely fill the budgetary needs. And the Neurotechnology Center is providing essential support currently. However, for a great many years, the Neuroscience Program P30 grant was responsible for providing that support. The website is shown for you here, and you can contact me via email, and it's always best to do that because I'm not always in the shop proper, so we can arrange to meet up if you need and just set that up through email. If you have any questions, I'd be happy to answer those for you. And if not, we'll see you in the shop sometime, I hope. Thanks.